No matter where you look, humans seek speed. Fast cars, instant messages, bullet trains. It's certainly true with our technology. As predicted by Moore's law, we've witnessed technology advances at unprecedented pace, and the rise of fast, smart, connected devices. The connectivity part of this equation, though, has perhaps been the weakest link. It has not kept pace as the rest of the technology, and while we've come to expect device connectivity wherever we are, that's not always what we experience. Wi-Fi, the platform that promises always-on, high-speed connectivity in our homes, in the workplace, in coffee shops, retail, airports, and even in flight, continues to advance yet still has some way to go. The reality is, today's connectivity can often be frustrating, with patchy network performance, too many users trying to connect at the same time, and users forced to wait for a connection or experience content buffering. Well, that could all be about to change. Enter the saviour of Wi-Fi connectivity, Wi-Fi7. The latest standard in connectivity and what some are calling a quantum leap forward from Wi-Fi 6, with its promise of nearly 5 times speed, improved latency and reliability, and projected launch as early as 2024. Is this the connectivity we've all been waiting for? By now, some of you may have guessed this is not Raymond Yin. No, I'm Mark Patrick, and I lead Mouser's technical marketing team in Europe. And I'll be your host for this discussion about Wi-Fi 7. Welcome to the Tech Between Us. With me today is Bruno Tomas, CTO for the Wireless Broadband Alliance. Hello, Bruno. Welcome to the Tech Between Us.
Well, thank you so much for having me. It's a great pleasure to be here with you today. And of course, Mouser Electronics, thank you so much for the invitation as well.
It's a pleasure for us to have you too, Bruno. Let's start with a little bit about the Wireless Broadband Alliance. What is the Wireless Broadband Alliance and what's the work that it does?
Absolutely. So we call it the WBA, so maybe I will just allude to that diminutive. But we are all about making wireless work. So of course, historically, WBA was formed 20 years ago. We just celebrated our anniversary. And Wi-Fi has been a key component in everything we do. So we are an alliance, a non-profit. We work with a global membership. I think one of the remarkable advantages of the work I do, and that's why I like it so much, is because we work with all types of operators, from mobile, cable integrated, but also infrastructure vendors, device vendors, semiconductor vendors, internet players, and all these minds coming together in a single room, working on the project, really makes a difference. So yeah, that's really about the WBA. We have work groups, technical programs. I like to say we are a very practical organization. So we try to solve business problems for our members. We have partnerships with other alliances like the Wi-Fi Alliance, the IEEE, IETF. But yes, so that's our tentative to help the industry move forward and deliver better Wi-Fi services in an integrated environment.
So it sounds very much that it's about bringing the community together, all the different elements of that community, and interoperability, I guess, making sure things work together as the user might expect.
Yeah, absolutely. I must say that on the first charter of the WBA, there was a nice use case that was, okay, you have your laptop, you are using Wi-Fi at the Singapore airport, and you had to go to Korea. How could you use the same set of credentials and identities to be able to use the Wi-Fi there without having to go through a whole new enrollment process? And ever since, things have become much more dynamic, and interoperability is what we know today, with the Wi-Fi growing a lot.
Well, and that is an amazing use case, and I think most of us don't think about just how simply we can do that as we travel around the world. But Wi-Fi has been around for some time, and those of us old enough remember the first Wi-Fi deployments back in 1997. And of course, as you've just described, it's that now ubiquitous technology, and it seems to gain greater adoption with each new iteration. So can you give us a sense of the scale, for example, that as, say, Wi-Fi 6 deployed, what were we talking about in terms of billions of devices and deployments with that?
Yeah, absolutely. And it always strikes my mind when you mentioned the year, still on the previous century, right, as we call it. But I think we are old enough to remember the first Wi-Fi deployments that still needed lots of ubiquitous technology that was not ready yet. And ever since, we see that every generation of Wi-Fi has kind of created a leap in terms of usage. So yeah, if you ask about the the scale. There is some very recent research, in fact, from IDC that really is a testimony to Wi-Fi coming into so many verticals and becoming ubiquitous. So IDC research just predicted that in 2023 alone, there will be 3.8 billion Wi-Fi devices coming to the market.
Astonishing.
Yeah, it's really even probably more impressive even to me because by the end of this year, there's the expectation that we have around 20 billion Wi-Fi devices in use. So if we think just in 1 year, you have roughly more than 20% coming to market, it's a great technology renewal cycle. Everyone wants to get stuck off the cables and do more and more wireless.
No wonder there's congestion on networks at times. But if you just think about the number of devices you have in your own home that connect over Wi-Fi, amongst other things, it's an incredible amount, really. And you can, I guess, quickly see how that scale would come. Yeah. So that's kind of up to where we are now, Wi-Fi 6, Wi-Fi 6E. And we know that Wi-Fi 7 builds on the additional spectrum introduced in Wi-Fi 6 and 6E. But what enhancements or improvements in performance can users expect? Is it just for the sake of it, we need a new version, or will it bring real change?
Well, I'm glad that, in fact, you made that question first, because typically the industry likes to talk about the features, what's coming new, but you mentioned the users. And I think that's in the end what makes a difference, because Wi-Fi being very centric B2C type technology, I believe, Mark, that's what is making a difference in every single generation. But yeah, to your point, I will just mention a few. I think everyone today talks about immersive AR, VR, and that's something that is not yet so preservative because the technology was not ready yet, and we believe it's a precursor to the metaverse. And you can see, Apple announced the new device, the Vision. The Meta also announced it, and it's a 6 GHz only device. So they really believe that now that Wi-Fi 7 built by design, supporting the new band and having this additional spectrum, that will cater to those use cases. But then I also like to think, and you mentioned us, our families, the way we work, the way we live. So Wi-Fi 7 and the additional spectrum is a lot about reducing the latency, the jitter, and these are basic use cases like video. So everyone does video today, but yeah, we have kids and they do some cloud gaming at home, and only with this additional spectrum and Wi-Fi 7 we'll be able to continue fostering some of those type environments that are really tough, especially if you don't have any other type of coverage.
So that sounds like it's largely about an increase in speed, an increase in bandwidth for a higher quality and improved experience from a gaming standpoint.
Yeah, you are right. I think Wi-Fi generations have been kind of intercalating two concepts. Let's augment the throughput capacity, or let's be more efficient. Kind of one generation is better at one, the other is better at the other. So Wi-Fi 7, by the name, by design, it was high extreme throughput, and that helped within certain environment to allow many more use cases. But then if you think about enterprise, to your point on the users, those are the users also, the IT managers, the factory workers that want to get rid of legacy SCADA systems. Again, still using wires because no Wi-Fi generation would cater to it.
And just being free of the wires, I think, is a great relief for many people, as we said earlier. I know that we'll come on to talk a little more in depth about some of the use cases later on, but also I wanted to ask about where we see these improvements in performance and perhaps new use cases that Wi-Fi 7 will enable. What are the fundamental changes in 802.11be, or otherwise known as Wi-Fi 7, that enable these additional features and performance? I know when we're going to talk about, I guess, things like modulation schemes and so on, but give us a sense of what's in there.
Yeah. Well, it's a great segue, in fact, now to go and do the reverse engineering to think about some of the use cases we mentioned. But maybe I could not get away of your initial question on the 1997 when Wi-Fi was coming to life. And maybe historically, if we just look into the last 3 generations, I would say, to respond to your question, that Wi-Fi was really device in control. So contention-based access. All the clients trying to communicate, trying to use whatever bandwidth was available on the IP, not as efficient, but it would work. With Wi-Fi 6, there was the introduction of OFDMA that would allow more command and control over the spectrum utilization. And finally, the AP was in control. So much more efficient and new capacity. And recently, 6E with the 6 GHz, allowed new spectrum to be available. That's clean spectrum, and no other devices would come into play.
So originally in that contention-based network, it was almost like creating a wireless version of Ethernet at that point, and sort of transferring what people were used to in Ethernet, or the principles of Ethernet, into the wireless world. But now what you're saying is, with OFDMA, we'll try and say this in case anybody is not sure of the acronym, orthogonal frequency division multiple access.
Yeah,
I think that's the correct term. But it's bringing those changes in, which really, as you say, allowed some control and command.
Absolutely. And, Mark, I love wireless, any type of wireless. And here Wi-Fi was smart, tried to emulate the successful story of cellular by adopting this type of modulation. So I must say that by design, when we combine the new features that you mentioned, and of course, spectrum, when you compare with the previous generations, is the first that allows 320 megahertz channels, that doubles what was available. And in the end, you double the throughput, right? And you get more speed. And once again, with the 1200 megahertz spectrum available by design, this means more capacity and interference mitigation. Then I would just also point out two more features, the multi-link operation. So that allows us to aggregate the different bands. So you can have, of course, the 6, but you aggregate with the 2.4 and the 5. And finally, I think the move from 1K QAM to 4K QAM also allows a higher density of the signal, around 20% improvement on the bit usage. And now if you combine what you were just mentioning on FDMA, new spectrum available, MLO. One very key point that the users can realize is that the theoretical link will be 5.8 gigabit per second. That's at least a 2.4x increase compared to previous generation theoretical.
Right, and that's now we get some kind of understanding of what's behind it and what users can expect then in terms of numbers. But I think reading about Wi-Fi 7, look, a couple of other points came up, and which will, I think, lead nicely into the next question, but resource unit puncturing. So being able to use available bandwidth in channels that's not in use at a particular point in time. And it's almost like TDM, I guess. It's giving those empty slots. Give us a flavour of that, because to me, the multi-link operation plus this RU puncturing seemed to be how the efficiency was going to be built into the bandwidth.
Yeah, you are absolutely right. And what I see on the discussions regarding Wi-Fi 7, and in fact, I must share, the WBA is going to launch a new exercise that we call Get Ready for Wi-Fi 7. Those were the type of assessments that the team was making. And when you think, for instance, about IoT, so there are many scenarios where a CIO or an IT manager will have to cater to many use cases within a factory environment. And of course, yes, the high throughput, the low latency type use cases, but then when you use, as you mentioned, TDM, when you use things like the resource unit utilization, you can just fulfill those packets within the factory. And I'm impressed always hearing stories of how many IoT devices are within the factory that use Wi-Fi. And in fact, they are battery powered and they can last for a few years. So we always have to care about the legacy. And I think that's one of the advantages also of that kind of backwards compatible utilization of the spectrum in a more efficient way.
And so when we talk about efficiency, reliability and latency and improvements in all of that in Wi-Fi 7, what you're explaining there, I think, is some of the ways that that's been built into the spec. So really interesting to hear about that. It does lead me to this question, though, which is how that efficiency is built in, how that spare capacity almost is utilised in Wi-Fi 7. It would seem an obvious win. Particularly my background is telecommunications, and I'm so familiar with your sort of 32-channel PCM link, which goes back 30, 40 years, but it's probably the first digital system that I met. Why do you think it's taken until the advent of Wi-Fi 7 to unlock this additional capacity? Was there a technology limit, as in hardware technology, or what's behind that? What's your view?
Yeah, I must say an unusual exercise when we are succeeding, why it took so long. Maybe from the discussions we have, the demands have been, tremendous, especially over the last decade. the pressure to increase the availability of not only the existing services, but new services keeps on growing. And the standards team, they have been reducing the cycles that it takes to bring a new generation to the real world. So the technology transfer is really decreasing. And when these teams are really setting up the market requirements document that leads to deliver a new generation, I think that's when they realize that without more spectrum, and during 20 years there was absolute no new spectrum coming to Wi-Fi, we would have this new world and these new possibilities. I think ultra-low deterministic latencies will take the experiences to the next level at the enterprise cycle. At the same time, we believe that the massive video streaming, even within a factory environment or within a certain corporate teleworker ecosystem, will also put more pressure on this. So, yeah, Mark, it's a great question. And maybe I need to also think a bit more on how we make it for Wi-Fi 8 and unlock opportunities we don't know yet.
You make me think of two other things, really. One, that it's been driven by kind of market need, by use case, by requirement, by the explosion in number of devices that are trying to connect. Yeah. But also the iterations will come faster, and that we may see Wi-Fi 7, A, B, C, D, E, whatever it might be as we get towards Wi-Fi 8. But I think, again, it's going to be down to the users and use case, isn't it? What's being demanded of the spectrum.
Yeah, I must share, Mark, taking that note that Wi-Fi 8 is already being scoped. So let's make sure we close the loop.
Sounds like a topic for a new podcast.
Yeah, absolutely.
Now, let's jump to a set of rapid-fire questions which come from our sponsor, Broadcom. Changing the world by connecting everything, Broadcom's innovative semiconductor solutions deliver voice, video, data and multimedia connectivity across multiple environments. Explore more from them by visiting mouser.com/Broadcom. What has been your most memorable country visited and why?
Oh, I would say Indonesia. Bali, I think, is completely different from everything I've seen until that time. And by the way, they are good, very good at technology. So I was lucky enough to have a project there. And I will never forget that I arrived and all this, in fact, wireless interoperability was working. And I was in this dream destination with the great technology we have been working over the years. So I will always remember as one of the most memorable visits I had.
So you saw the fruits of your efforts in the WBA whilst you were in Bali, and you were there on a business trip. So funded by your business in some way. Fantastic. If you were not CTO of the WBA, what else would you be doing?
Well, Mark, I still believe in another life I was a professional football player. So unfortunately, career didn't bring me there. But I guess I would be going into the pitch every day and feeling the crowds. It should be an amazing sensation. But no, we have the wireless crowds to please.
And certainly you're doing that. That's a really interesting backstory. For myself, a musician, I think most people that know me know I was a professional musician for a while, and keyboards technology, of course. And here we are working in the electronics industry.
Well, still time for a DJ career, Mark. It's quite trendy.
We're still doing stuff, but it doesn't pay the bills. Outside of work and the WBA, what do you do to relax, switch off, unwind?
Yeah, so I think this sticks for life. Whenever I can, I try to do sports, from cycling, running, play with friends. I think is really good for our current fast-paced life, and especially when you have kids, you do lots with them, we have lots of fun, but it's your time, your moment.
Yeah. And I think the important contrast of doing something completely different, but also the activity as well, from your point of view, the activity sounds like the real contrast for you. Now, as the CTO of the WBA, I'm imagining your home is bristling with connected devices. So what is your favourite connected device at home?
Well, that's a very interesting finding I had a couple of days before. So now I have 3 kids, and I think before kids, I was counting like 3-4 wireless devices in my home. Now it's about 6 per kid, so I'm about 30 devices, and then you have, the connected fridge, lots of connected devices. But I must say that my favorite device currently is Alexa. So everyone is having so much fun with Alexa. We move it around. There is the mute button. And sometimes we joke that some company knows everything about our life. And we joke that, well, they switch off this log as soon as they start hearing all that's going on here. But yeah, Mark, I think that really made a difference in our life. And seeing the kids interacting with the voice AI agent, it's really impressive. And wireless must be there. So it's very painful because sometimes Alexa is not working and we just ask, Alexa, are you connected? And she says, well, my Wi-Fi is great, but then it doesn't work. But yeah, it's lots of fun.
You ask Alexa whether Alexa is okay.
Exactly. Are you connected, Alexa? And she says, yes, I have a Wi-Fi connection.
Such is the penetration of voice-activated technology into our lives now. Thanks for joining us for part 1 of our conversation with Bruno Tomas. Look out for our next episode as we dive deeper into Wi-Fi7. If you'd like to learn more about this technology, the Tech Between Us podcast is just one piece of Mouser's in-depth look at this subject. Explore the entire Empowering Innovation Together content series at mouser.com/empowering-innovation for technical articles, use cases, and more.
A global leader in semiconductor solutions for wired and wireless communication, Broadcom delivers engineers a broad product portfolio of state-of-the-art system-on-a-chip and embedded software solutions for markets in data center, wireless, industrial, and more. Broadcom is changing the world by connecting everything. To learn more, visit mouser.com/Broadcom.